Hey guys. Okay, we will start this video with example 4 and section 3.1. Given the graph of the function below, let's call this function f, sketch a graph of the derivative of f. Okay, so this is very, very common. So I'm going to make a chart or another grid over here. And please, if you are going, number one, oh, that's so ugly. I don't want you to graph more than one or two graphs or function in one coordinate plane. Okay, if you have three, it's just too busy. If you have two, at least you can label it. So over here, you're given a regular function. Over here, I am going to be graphing the derivative of it. It's called f prime. So what we are going to start with is we are going to identify where your derivative is 0. Okay, so tactics for sketching f prime. Okay, let's start with the first one, easy one. Look for the obvious slopes. Okay, most obvious are when the slope is 0. The slope is 0 means I'm looking at a horizontal tangent. Remember this? We talked about this before in our last unit. Horizontal tangent is when the slope is 0. When are they? If you're giving a graph, the slope is 0. Okay, when is a horizontal tangent, which is, as you can see, at the vertices. Okay, since I have 2 here, these are them. Now, x is still x. Okay, so x is in f of x is the same as x in prime. Okay, so looks like I'm gonna have x is 1 right here, right? X equals 1, so that's my first one. So what does that mean? Well, when x is 1, the slope is 0, which means f prime is 0. Okay, that's why the tangent is horizontal. Another location is when x, let's just pretend that this is when x equals to -2. So at -2, it's another location that your slope is 0. That's another location that's going to give me a horizontal tangent. That's why this is not labeled f of x anymore. As you can see, this is now labeled f prime of x, okay? Next, what do we do from here? Okay, tactic number 2. Let me just repeat what I just said. Remember x values of f prime is the same as x values in f of x. Okay, so the horizontal values are not changing, it's just the vertical values are changing. Okay, then step 3, just to kind of have an organization, I tend to make a chart. Okay, make a chart using x values. And no, you don't have to follow these tactics. The more you practice, the quicker you will be able to sketch these out. So what's happening is that you have 2 locations, okay, of when f prime is 0. So the first location is x equals to 2, and the second location is x equals to 1. Okay. So what do I do with this? I'm going to make a chart here. Just like that, okay? So I'm going to call this x value, and I'm going to have this f of x. Yes, regular f of x. I don't need a lot of space, and this is f prime of x. And I'm going to call this left. So over here is where I'm going to call left side of x equals to -2, okay? Left side of x equals to -2. Over here is in the middle, because it's in the middle. And over here is on the right side of x is 1. What am I trying to do? As you can see, okay, is this. On the left side of -2, on the left side of -2, is your original function increasing or decreasing? Okay, so as you can see, it's increasing. Because on the left side, the original function f of x is increasing, your derivative is positive. Okay, what do I do with that information? Well, positive means on the left-hand side, which is this right here, positive means I'm above the x-axis. That's what it means, in which now I erase a circle. Okay, so that's what it means. Now, in the middle, okay, in the middle, your regular f of x function, is that decrease or increase? That is decreasing. Okay, what does that mean by decreasing? Decreasing is when the derivative is going to be negative. That's right, that's how they are related. What does that mean? So in between -2 and 1. Negative means I'm below, oh, it looks like a smiley face, below the x-axis, okay? Right now, I'm not very picky on the steepness of it, okay? I'm just looking for above and below. Then, what's happening on the right-hand side of x equals to 1? That is increasing, okay? Increasing, just like, let me erase this line. Increasing, again, that means f prime is positive, okay? So what does that mean? Positive means I'm above the x-axis, okay? So the derivative of a cubic, so let me just erase all the stuff I marked here. The derivative of a cubic is a quadratic. Isn't that beautiful? And that's how you need to, that's what you need to do to sketch it out. Again, I'm just going to say it again. I'm just going to ignore the steepness for now. We will talk about that when we get to chapter 4. Okay. Example 5. Sketch the graph of a function f that has the following properties. Okay. Doesn't this remind you of chapter 2 where you have to sketch and then I gave you a bunch of properties again? Kind of like that, but now we're dealing with derivatives. So, sketch the graph of a function, okay? A function means I'm looking for the original. And I'm going to make a coordinate plane. And I'm going to kind of talk to you guys as I go along with my thought process, okay? 1i says f of x, okay, has an algebraic value. When x is 0, y is 0. So what does that mean? I'm going to go and plot a 0, 0, okay? So this is what it means by f of 0, y is 0. You have an algebraic value, okay? 2i says the graph of f prime, the derivative of f, is shown below. Oh my. And then 3i says f is continuous for all x. So that means I cannot, okay? This means I cannot have any holes or infinite discontinuity or what else are we thinking about? Jumps, anything like that, okay? So I'm going to use f prime to finish up the rest of my graphing. So here's the f prime graph, okay? What does that mean? That means, let's look at it. The slope, see this right here? The slope starting from 1, this is when x equals 1, and on, it's always 2, okay? This is how you read it. The slope is 2 from 1 all the way to infinity. How does that affect your f of x function? Let's go and label this. This is no longer just, so you have to label because you don't know, I don't know what you're trying to graph, okay? Just like the previous example, we were graphing f prime, now we're going backwards. We are trying to graph f of x. So where is 1? Okay, let's make some tick marks. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Well, it says the slope from 1 and on is 2. Well, I'm going to make some dash lines for now, and then later I will erase because I don't want you to think that these are asymptotes. Here's 1, right? X equals 1. From 1 all the way into infinity, the slope is 2, okay? Then let's go to the next line. Let me use a different color. This guy right here in the bottom, okay, this guy right here is saying that the slope from negative infinity all the way to 1, is negative 1, okay? So again, okay, the confusing point right now is when x equals to 1. As you can see, the slope does not exist. See, okay, so this is important right here. I think my computer's frozen, so let's... Okay, so I want to pinpoint something really quickly. The slope at 1, as you can see, does not exist, okay? Okay, so the derivative at x equals 1 does not exist, okay? Okay, so let's do it. The slope, okay, from negative infinity to 1 is negative 1. This point is my starting point. It's on the left-hand side of 1. So I need to have a slope of negative 1. What does that mean by slope of negative 1? Go down 1, left 1, right? Down 1, left 1. Or I can go up 1, right 1. Up 1, right 1. That's what it means to have a slope. Up 1, right 1. So here is the dot. These are the dots that I needed to graph f of x, okay? And again, this is pretty confusing, but you kind of need to know how to read your f prime graph. So as you can see, from negative infinity to 1, the graph, this is my f of x function right here, okay? Does it have a slope of negative 1? Sure it does, right? Remember, I just counted it. I went down 1, right 1, or up 1, left 1. So right there has a slope of negative 1. Now let's go from erasing. I need to erase a couple things. It's too busy. Okay. Now let's go from 1 to infinity. The slope, okay, from 1 to infinity is 2. It's positive 2. What does that mean? I'm just going to count. That's all. Up to right 1. Up to right 1. That's what it means by having a slope of 2. You're just counting, okay? There you go. So, all right, the slope does not exist at x equals to 1 because, look, there's a hole. But your condition said that f has to be continuous, okay? So what that means is I need to fill this in. Yes, okay? Let's talk about this. It's filled in, meaning that the slope does not exist at x equals to 1. Why does it? How come the slope does not exist? Because the slope coming from the right hand and the slope coming from the left hand are not the same. One of it is 2 and one of it is negative 1. They're not equal. Therefore, the derivative does not exist. Remember the definition. The derivative, for the derivative to exist at a point, the slope or the limits has to exist, okay? So for this case, it doesn't exist, even though it is a whole, okay? Now, this is slightly different from chapter 2, okay? So in chapter 2, we were not talking about the slope. We were not talking about the derivative. We were not talking about the tangent. In chapter 2, we were just simply finding the limits of f of x at x approaches 1. This exists, okay? This is definitely exists. It is negative 1, okay? But the slope is different from the height, okay? This right here is the height. I want you to understand the difference between the two. This right here is the slope. The limit as h approaches 0 of f of a plus h minus f of a all over h. This right here is talking about the slope of a tangent. Slope of tangent, okay? So for this derivative to exist, the slope from the right and left has to exist. Okay, so hopefully this helps you differentiate the two different kind of limits here. All right, I'm just going to take a break right here on this one.